Hey folks, Mrs. White here. So today is day one of practicing. When I see you folks again on Monday, that will be day two of practicing. And then after Monday, whenever you are ready, you are welcome to take your Chapter 6 test. I know at this point that Chapter 6 has been a lot. And I think that after today, you will feel like Chapter 6, just this section on solving, is a lot. I feel you, I get it, it is a lot, especially to try to attempt to do with remote learning. So, what I've decided to do, and I haven't necessarily okayed it with everybody, but we're going to do it anyways, is I'm going to make this chapter exam open note. It cannot be open homeworks. I don't want it to be that you just have every homework out or the review with the key out. And I'll make that very specific in the message that I send to your parents. But you are welcome to have whatever notes you've taken from any of the previous videos. Since review starts today, I would encourage you maybe to go back if there's sections that you're struggling with, and maybe you'll identify those on Monday when we do our official review day. Go back, rewatch the video, take any notes that you need to. Again, I don't want to see homeworks there. I don't want to see a printed out review sheet, and I will let your parents know that that is available to you online and that should not be what you're looking at. Instead, it would be any handwritten notes that you've done. So, with that in mind, if you need to go back, you have everything available to you, okay? Beef up your notes, make sure you're ready so that you can knock it out of the park at the end of the year this year. So today is going to be a pretty challenging day, I'm going to be honest with you, because we've learned a lot of different ways that we solve exponential and logarithms. As you can see right here, it's the key to the last homework that I had for you, and the secret message was that I miss you all, and I totally do miss you all, and I know that this unit is hard, and I know that it would have been a lot easier were we all together, and you know, we're not. So I'm hoping that by allowing you to have your notes, you see that I see that it's a hard chapter, and that I'm trying to encourage you to do a little bit extra review so that you can use those pieces and parts on your exam. So my work is here. If you stopped by at office hours, we went through a handful of these problems. And as always, I'd encourage everybody to attend office hours. So my actual last office hours are going to be tomorrow, because I will be holding the review on Monday, and then after that, you will be taking your exam. If you have any questions about the test, then you would be invited to pop me an email. I'm not going to hold office hours where we discuss the exam, though. Okay? So last office hours is tomorrow. If you have any questions, please touch base. Okay? Please touch base. So let's take a look at all the different ways that we've solved exponential and logarithmic equations before. So we did exponential, we did logarithmic, which this was just some loose ends, but we had all those logarithmic properties. We had a lot going on with that. We talked about natural log, and we talked about the common log, which remember is a base 10, and the natural log would be a base e. And then we also discussed change of base formula. All of these, okay, all of these are tied in no specific order into our activity today. All right, so we're going to start an activity together. You're going to be asked to finish it on your own, okay? And I know it's going to be a lot of work. It's hard work. I assume that many of you will get stuck and or have questions. That's the point, is that we practice hard so that when you take the exam, it doesn't feel so bad. So let's take a look at what the example or what your activity is going to be. So if you've gone on Google Classroom already, you've seen it's brought you to this Google Sheet activity. And let's just take a quick look at this. What you have in this activity is 4 by 4, so 16, and we're going to do 3 of them. So 16 exponential and logarithmic problems here, okay? And what you're going to do is you're going to solve it, and then you are going to type your answer in any of these boxes. So say we get the answer of 5 at one point, okay? So we would come here, we'd type 5. It could be here. You could start it wherever you want. It doesn't matter, okay? But once you solve it, you're going to come over here. Maybe our answer shouldn't be 5. Let's say it was 9, because 9 is actually on that sheet. So you're going to come here. You're going to type in your 9, okay? Say we did this problem and the answer was 9. We're going to look. The previous answer was 9, right? We just got that, so this will be the next problem we solve. Okay, so let's say we solve this up and we get 1/8. I'll come here right next to the 9, okay, and we're going to go clockwise. You're going to type in right here. Whoa, I can't type it in right now. We'll make it work. 1/8. Okay, then you'll come to the sheet. So we did this one, which gave us 9. We did this one, which gave us 1/8. So we're going to solve this one next. And that's going to give us another number, which should be on one of these sheets. And what's going to happen is eventually, as you solve all 16 problems, your last problem should give you the answer that was attached to your first card. So if this was our first card, our last answer is going to be negative 0.9197. Now you can see some of these are fractions, some of these are decimals. Because they're decimals, and we're going to do one that's going to have a hot mess decimal. Usually the decimal answers are the result of using the base change formula, where we have to do you could do natural log, but you would do like your common log of your of piece over your common log of your base. And again, we're going to do one of those, so if it feels like that what I just said was familiar, but you're not quite sure, then don't worry about it. So you should open this up, make yourself a copy, and then this will be what you stick back to me on Classroom. I would also encourage you to add a new slide. So you might go what do we do for this? Slide, new slide, and then put your work here. In fact, I'm going to leave this and I'm going to label it work. So you can add as many slides as you need to with the heading of work on it, and I can see that you didn't just kind of figure out the order and write them on down, okay? This assignment, I assume, will probably take you close to an hour, which is why we're going to do 3 together, and I'm going to try to make this video as short as possible, okay? So let's go back to where I can write on it and take a look. So here are all the problems that you could potentially see, and all of the answers to all of the problems. So I'm going to start by going over this one because this is exponential form. This is actually the stuff that's been the longest since we've seen. Then we'll do this problem on exponential properties. Not exponential properties, logarithmic properties. And then we'll do this one because I assumed people thinking the negative in front of the log might be tricky. So let's solve it and avoid that question. Okay, so we have one hard-looking exponential one that involves logarithmic properties, and then some weird freaking negative coefficient. Okay, so let's start off with our first one right here. So hopefully you recognize that this is an exponential form. Whether we're solving an exponential or we are solving in logarithmic form, you want to always get your log pieces simplified and then alone. In exponential, you want to get your exponential piece alone first. So I notice in this problem, this is my exponential piece. It is not alone. It is being times by 4. So my first step is going to be to get rid of that 4. Okay, and my variable is right up here, right? So really my goal is to get this w alone and positive if I can. Well, I can't get it alone till this chunk's alone. I need to get rid of the 4. So I'm left with 16 to the 8w minus 7 equals, and then 172 divided by 4 is actually 43. I did it on a calculator ahead of time. So at this point, this is a simplified. My exponential piece is by itself. Okay, it's just one exponential piece, and I have a constant over here. And you might get stuck now. Like, what do I do? Okay, whenever you're stuck, if you have something going on one side and a constant on the other, you change the form. So this is currently an exponential form. I'm going to change it to logarithmic form. Okay, so whatever your base is that holds up your exponent is going to be the base of your log. Your of piece is from the other side of your equation, so 43 equals, and then 8w minus 7. And this is just normal changing things from exponential to logarithmic, right? We take our base, this is our of, this is on the other side of our equal sign. Okay, and you could always check 16 to the this equals 43. Oh yeah, I did do that right. So you might be like, Mrs. White, this didn't really help, but it did. It brought a variable down from being in the exponent to being like over here, and this side doesn't look bad at all. This side is a little bit of a mess. The way we're going to go about solving this, and we're actually going to figure this out right now, is I hope you notice there's no w here, there's no w here. So I can use my base change form. Okay, and this is what we learned last class as we were talking about the common log, right? Okay, not last class necessarily, but last Thursday when we were talking about the common log. So at this point, you can take your log of your of piece, 43, and take the common log of your base and put it as the base or the denominator of your fraction. And we can actually calculate what that is. Okay, we don't have a button on our calculator for log base 16, but we can do log of 43 divided by log of 16. So I'm actually going to take a second. We'll solve that. So let's clear this out. I'm going to do log of 43. So I do have a log button right here. Log of 43. I'm going to close that parentheses, and I'm going to divide it by log of 16. And close those parentheses and press enter. And I'm going to get a hot mess decimal. Remember how I told you decimals are going to happen here? This is going to be an instance where that's going to occur because we had to do our base change formula. So 1.3566. Okay, I'm going to round 4 places out because that's what all my answers are. So 1.3566. 1.3566 equals 8W minus 7. Now, although it's a decimal, we can still compute with stuff, right? We're going to add 7. We're going to add 7. That's going to give us 1 plus 7 is 8.3566 equals 8W. And then my last step is divide 8. And I'm left with W equals this. And I'm just going to clear this out. And then what was that again? 8.3566 divided by 8 equals 1.044, and I'm going to round here 6. 1.0446. So I should have this answer in one of the corners of one of the things. So I'm going to go back here. Okay. I'm going to look 1.0, right here. Okay. So from this card, and you may start here. Maybe you start here and you go to this card next. It doesn't matter to me. Okay. I'm going to go to the circle. I'm going to type in 1.0446 into the circle, and then I'm going to go to this problem. Then I would solve this problem, look for the answer in one of these corners, okay, and then keep going from there. Now, this is another exponential problem. I'm not going to do it, okay? It's going to be solved very similar to this one, but first you should subtract 9, and then divide by -3 and divide by -3, okay? Just food for thought. That's got to happen. Okay, so we're not going to do that because I want to do, again, different types of problems. So you don't have to start there, but at least you have the answer to this card when you get to it. Let's go to this problem now where we're going to look at our logarithm properties. So here I have a log base 9 minus log base 9 equals a log base 9, which is really nice because eventually those logs are all going to cancel out. If I'm subtracting 2 logs, I can take my of pieces and divide them. This becomes the top, this is the bottom. So right now I technically have, if I combine those together, let's just stick a little there, log base 9 of numerator, denominator. So 3n plus 2 over 7 minus 4n equals log base 9 of 2. Well, this cannot be simplified. It's one log on one side, and I have the same log with the same base on this side, as simplified as it can get. If you have log equals log, they cancel. And this is just an equation to solve now. I have a fraction equals a constant, so I'm going to times by my denominator first. And when I send it over here, I want to make sure I put it in parentheses so I remind myself to distribute. And we've seen these. These happened a lot on that maze, right? Where we had a fraction and then we had to send the denominator to the other side. So 3n plus 2 equals, and then 2 times 7 is 14. 2 times -4 is -8n. I'm going to move all my n's to the same side. I'll add these over here, which gives me 11n. I'll minus this over here, which will give me a 12. So I have 11n equals 12. I'm going to divide by 11, divide by 11. Okay, and I get n equals 12/11. Now, when we're dealing with logarithms, and I should have mentioned this in the previous problem, our of piece can never be negative. So this is currently a positive number, correct? So like if I plug a positive here, it's going to stay positive, and then I'm adding, it's going to stay positive. But in this problem, there could be a dilemma, right? Okay, if I have 7 and I subtract 4n from it, if this product is larger than 7, I'm going to get a negative, and this would become a no solution. So I should check that really quick. What is 12/11 times 4? And just make sure it's not bigger than 7. So I'm going to do 12 divided by 11 equals, oh, it's not going to matter, times 4 equals, I get 4.36. So 7 minus 4 point whatever isn't going to be a negative, so this actually works. So my answer should be 12/11ths. So let's go back. Is there one of these that, oh yeah, right next to it. That's interesting. Okay, so we have a 12/11ths here. So if you solve this one first, it's going to connect to this one. Then we'd solve this one, okay, and then go to the next one. And this one has our common log in it, just kind of food for thought. Remember, that's a base 10. But I notice ahead of time that this is log equals log. So once I simplify this up here, okay, then I'm just going to be able to cancel each of those out. And it looks like it's going to be a quadratic. It could potentially have 2 solutions, or no solutions, or 1 solution. So we're not going to do that one because, again, that's log properties. We already did one of those. Let's take a look at this one that has like the negative in front. There's actually 2 ways you can solve this. One way is you could take this negative coefficient, okay, use your power property and make it a -1 on top of this. So if we chose to do that, and I'm saying chose because there isn't another way to do this problem, but I feel like that might have been what you would have thought to do. We're going to rewrite it as log base 6. Now, when you have a negative exponent on anything, it means change its location, right? Move it to the denominator. So now I'm left with this, okay? I've simplified my coefficient. There's nothing being added or subtracted. This side of the wall is as simple as it can get. And then I have, so a log equals a number. If I have something going on one side and it equaling a constant, then I need to change the form. Okay, that's what I want drilled into your head. If you have a log or an exponential on one side and just a constant on the other, change the form. Okay, so I have 6 to the 0 power equals this fraction. Now 6 to the 0 equals 1/8w. Anything to the 0 power is 1. So 1 equals 1/8w. I'm going to multiply by 8w on both sides to get it out of the denominator. I end up with 8w times 1 is just 8w equals 1. Divide 8, divide 8. My answer here is 1/8. And if I plug in a 1/8 here, I'm going to get a positive of piece, right? It's going to equal just 1. So you could have treated this as an exponent. I also want to remind you folks that this, in application of not log properties, but just in general, is a minus also, right? It's a leading coefficient of 1, but that could also be written as a minus. Well, I could have just added log base 6 of 8w to each side. Oops, add log base 6 of 8w to each side. Now, by adding it to this side, I've now made it positive. And when I do 0 plus that, it just equals it. And now there's nothing over here. So essentially, I moved this chunk to this side, and I moved this chunk to that side. And now that it's positive, I can not have to worry about that negative sign. So I still do the same work. I notice there's a constant here, and there's a log here, so I'm going to change the form. It's going to be 6 to the 0 equals 8w. So 6 to the 0 equals 8w. What's anything to the 0? It's 1, so I end up with this step right now, right? We just skipped an extra step in here. So I'm going to divide 8, divide this 1 by 8, and I still get w equals 1/8. And if we go back to our work, or our original problem, I have a 1/8 right here. So from this problem, I'm going to go over here and solve this. So eventually, you can see I've done 3 problems for you out of the 16. Okay, so you're going to have 13 left. It's a lot of work. I get it. And it's a lot of thinking when you have to make choices, and that's hard. But they should all lead into another problem. If your answer is not on this sheet, you did something wrong. I don't mean to be sassy about it. If you have any questions about any of these problems as you're working, take a picture of what you are working on and send me that. Okay, take a picture of what you're working on. It's really hard for you to try to talk through it in an email when we're dealing with these problems. Okay, so take a picture and I will try to give you feedback on the work you've already accomplished. Otherwise, I'd really prefer you folks to show up to office hours tomorrow, okay? And we can start wherever you want to start and just continue from there, okay? I look forward to hearing from some of you. I know this is a challenging activity. I want you to give it a good chunk of time, okay? It's as we're starting to study for that test. And then over the weekend, think about, do I need to beef up my notes? Okay, is there an area where I could add a little bit extra notes? If so, go back and do it so that you're starting to study and preparing for the test for next week. We have 1 week left of school, folks. 1 week, Okay, review activity Monday, test when you're ready, and that's it. You're done. You're free from remote learning as of Friday of next week. Okay, folks? I hope to hear from you if you need help. If not, I hope that things were clear and you're good to go. I will talk to you later. Bye.